Welcome to our video class, part 4 of set, relation and mapping. Today also we take few problems. First of all, A and B are two sets containing 4 and 2 elements. Then the number of subsets of A cross B having at least 3 elements is options 219, 256, 275 and 510. Let us see what is the exact problem. Two sets are given, A and B. A has 4 elements, B has 2 elements. A cross B is a set, Cartesian product of A and B. Its elements are x comma these pairs x comma y, x belongs to A and y belongs to B. So we have to find how many elements are there in A cross B which contains at least 3 elements, 3 or more, 3, 4, 5, 6 and so on. So let us see how many elements are there in A cross B. A has 4 elements, B has 2 elements. So 4 into 2, that is 8 elements are there. So number of elements containing A cross B is 2 to the power 8. 2 to the power this 8. It is simply 256. So 256 elements are there in the set A cross B. So of them they have null set. Then a subset is containing only one set, containing 2 sets, containing 3 sets and so on. We have to find the number of subsets containing 3 elements, 4 elements, 5 elements and onward. So for that purpose, find number of elements containing null set, which is simply one null set, containing one element. Actually A cross B have 8 elements, so containing one element it is 8C1, that is 8. Containing 2 elements is 8C2, it is 8, 7 by 2, 28. And containing null set it is simply 1. So we get one set, one element, null, no element, 0 element, plus 1 element, plus 2 element is equal to 37 elements. So there are 37 elements containing null set, and containing only one element and containing only 2 elements. So all of rest of them, from this to that, all elements are more than 3 sets, 3 elements. So the required number is 256 minus 37. So it is equal to 9, 2. So 219 elements are there in A cross B, which contains 3 elements or above, 3 elements or more. So our option is 219. Now our second problem. Let P theta such that sin theta minus cos theta is equal to root 2 cos theta, and Q theta such that sin theta plus cos theta is equal to root 2 sin theta. Then which of the following is true? Number one, P is a subset of Q and Q minus P not a null set. First option is this. Second option is Q is not a subset of P. P is not a subset of Q. And last option is P is equal to Q. Let us see clearly what is the exact problem. P is a set of all thetas such that theta is solution of this equation. So it has infinite number of elements. Similarly, Q another set of theta such that this theta satisfies this equation. Then we have to find whether this or this or this or that. Now the set P, its equation is that, which is that equation? Sin theta minus cos theta is equal to root 2 cos theta. That is, sin theta is equal to root 2 plus 1 cos theta. That is, cos theta is equal to this by that, 1 by root 2 plus 1 sin theta. That is, this is equal to root 2 minus 1 by this into root 2 plus 1. This into that is 1 into sin theta. This is number one. And from this is solution of, that is, this is set theta which satisfies this equation means that equation. Similarly, for Q, theta is cos theta plus sin theta root 2 minus root 2 sin theta minus 1 sin theta. That is, cos theta is equal to root 2 minus 1 into this one. So you see, cos theta is equal to root 2 minus 1 into sin theta if solution is the set P. Similarly, for Q, solution of this equation is the set Q. But you see, they are identical, they are equal. Therefore, all members of P must be members of Q. Therefore, our option P is equal to Q, this is correct. Now let us take our next problem. Let F is equal to R to R is a mapping where fx is equal to kx plus 2 if composition F is a identity mapping, IR identity mapping, then value of K is options 2, 1, -1 and -2. Now I discuss the problem once again in detail. If R to R means set of real numbers, if R to R is a mapping where fx is given by kx plus 2. K is unknown constant here. K is unknown constant here. And given that if composition F this become a identity mapping, it means if composition F x is equal to x. From this relation, we have to find the value, exact value of k if exists. So it is actually, it gives f of composition of fx is equal to x. Fx means f of kx plus 2 is equal to x. Fx is this, so f of that is equal to k into x. This x means that kx plus 2 is equal to x. That is k square x plus 2k plus 2 is equal to x. It must be satisfied identically because it is identity. This is actually equal to, this happens for any x, this is equal to that. So we get here k squared minus 1 into x plus 2 into k plus 1 is equal to 0. Now this will be satisfied identically if this is 0 and this is 0. That is, we must have k square is equal to 1, that is k is equal to plus minus 1 and k plus 1 is equal to 0, that is k is equal to minus 1. So from these two, it is clear that k is equal to minus 1 satisfies both. Therefore, our option is k is equal to minus 1. Now, next problem. Next problem is this: f is a function from R to R and G another function from same thing R to R, where fx x by x plus 1 and gx x by gx is equal to x by 1 minus x. This is 1 plus x, this is 1 minus x. Then f composition G inverse x is, what is the element of f composition G, that function, its inverse x, what will be that result? So options are here. Options are x, number 2, x by 1 minus x square, x square by 1 minus x square, and 1 plus x. These are the options. Now, actually, two functions are defined here. Fx from R to R, gx also R to R, and law fx is this, and function gx is this. So, first of all, find f composition g x is equal to f of gx, but gx is equal to x by 1 minus x. Now, function f and its argument is this. So, it is equal to, in numerator x means the whole thing, x by 1 minus x by x plus 1. X means 1. The denominator, simplify first denominator. It is x plus 1 minus x. Cancel, so only 1 of x plus 1 minus x. So 1 by 1 minus x. So 1 minus x cancels. So it is simply x. Tahle we get f composition gx is equal to x. Then inverse function of it will be the same point itself. Therefore, f composition g, its inverse is equal to x. So our first option is correct. Now, next, let us take the next problem. If fx plus 2 f of 1 by x is equal to 3x, x not is equal to 0, and S is a set of all points x such that x belongs to R, real quantity, and fx is equal to f of minus x, that is odd function. Then number of elements of S, options are 0, 2, 4 and 5. Let us see the problem properly. Fx is a function such that fx plus 2 times f of 1 by x is equal to 3x, x non-zero. And S is a set of x. What is x? X is real, and it is such that fx is equal to f of minus x. Then question is, how many points are there in the set x satisfying all this? So you see, fx plus 2 times f of 1 by x is equal to 3x. From this, we can very easily calculate the functional value of fx. How? Given that, this, first of all, you replace this by, this is equal to that, replace x by 1 by x. This become f of 1 by x plus 2 f of, this become x is equal to 3 by x. So ultimately we get two relations involving fx and f of 1 by x, 1 and 2. From these two, very easily uh, we can find value of fx or f of 1 by x. Multiply this by 2. So 2 f of 1 by x plus 4 f of x is equal to 6 by x. And write this. It is fx plus 2 times f of 1 by x is equal to 3x. And now subtract. F of 1 by x will be cancelled. Subtracting, we get 3 fx is equal to 6 by x minus 3x. Therefore, fx is equal to 2 by x minus x, 2 by x minus x. So we get fx. So functional value is known to be fx is equal to this. And moreover, it is given that S is a set such that x is real and fx is equal to f minus x. Fx is equal to f minus x, it gives 2 by x minus x is equal to minus 2 by x plus x. So we get, taking this into that side, 4 by x is equal to 2x, that is 2 by x is equal to x, that is x squared is equal to 2. So x can be solved from there, x is equal to plus minus root 2. So we get two values of x which are members of S, satisfying this, this and that. So we get S has only two elements in the set satisfying this condition, and that condition. So two answer. Our next problem. If fx is equal to x square and gx sin x belongs to R, that is x is real quantity, then set of all x satisfying F composition G composition G composition F x is equal to G composition G composition F x is set of all x. We have to find now set of all x satisfying this result, and options are root over of n pi plus minus root over of n pi and n pi square in for all cases n is equal to 0, plus minus 1, plus minus 2, and so on. Two functions are given, fx and gx, x real, and this condition is satisfied. Then what are x? Either these or that. In every cases, it has infinite number of elements because n is 0 or plus minus 1, plus minus 2, etc. It is actually 0 plus 1 plus 2, not plus minus. Now let us see. We are given this is equal to that. Left hand side is F composition G composition G into Fx is equal to F composition G and Fx is x square. It is equal to F composition G of x square. G of x square, G of x is sin x, so it is equal to sin x square. F composition G sin x square, F of composition of G sin x square, G sin x, the Gx is this, G sin x square is instead of x we have to write sin x. It is equal to sin x square means sine of sin x, sine of sin x square, gx. G of that means sine, and this means sin x square. So it is equal to sine of that and is equal to f means x square, fx means x square. So we get sine of sine x square its whole square. Because fx is x square, f of that is this thing whole square. And on the right hand side, it is G composition fx, means fx is equal to G composition G, fx is simply x square, is equal to G of G composition G of x square. Gx square is, Gx is this part is sine x square, and Gx square is sine x square. So it is equal to sine of Gx is sine x, sine of this sine x square. Now given that it is equal to that, this means this is equal to that, and right hand side is this. So we must have sine of sine x square its whole square, this is equal to sine of sine x square. So sine of sine x square, taking common, we have sine of sine x square minus 1 is equal to 0. So we get either this is 0 or this is 0. if this is 0, sine of sine x square is 0, means sine x square is equal to 0. That is x square is equal to n pi. That is x is equal to plus minus root over of n pi. And if this is 0, then we get sine of sine x square is equal to 1. That means sine of theta is equal to 1. So that theta is equal to pi by 2. So we get sine x square is equal to pi by 2. But this is impossible because pi by 2 is greater than 1. So sine x something is greater than 1, not possible. So it is impossible. So only thing we get, x is equal to plus minus root over of n pi. So our answer is that. Next. Mago. Next problem is if x 4 to the power n minus 3n minus 1 n belonging to capital N, means n set of natural numbers, and y 9 into, not g, 9 into n minus 1, n belongs to capital N, same meaning. Then x union y, this is capital X union y, options x, y, (9, 18, 27) and other is next option. I cannot read it. One more options are there. Achha, now y set y, it is equal to, by putting n is equal to 1, 2, 3, 4, etc. This set is 0, 9, 2 into 9, 3 into 9. That is, it is all multiple of 9, set y. And you see, this is 4 to the power n minus 3n minus 1 can be written as 3 plus 1 to the power n minus 3n minus 1. It is, in fact, 1 to the power n means 1 plus nc1 into 3, 3n, then plus nc2, 3 square, plus nc3, 3 cube, so on, minus 3n minus 1. So these two cancels. From here, clearly all terms are divisible by 9. So this is terms divisible by 9, but they are not exactly 9, then 2 into 9, then 3 into 9. This is not that, because its first term is, by putting n is equal to 0, it is 1 minus 1, 0. Second one is 4 to the power 1 means 4 minus 3 minus 1. So 4 to the power 1, 4, 3 minus 3, 0. Then putting n is equal to 2, this is 4, putting 16 minus 7, this is 9. Putting n is equal to 3, 64 minus 9 minus 10, that is, it is 54, and so on. That is, its terms are 9, 0, 9, 54, etc. That is, 54 is there, 9 is there, but all terms are not present here. We have to find x union y. So it is in fact, they are all multiple of 9. They are multiple of 9, but not all terms are that. Anyway, this become y. Correct. Therefore, x union y is equal to y. One more problem I will discuss. If from minus pi by 2 to pi by 2 to r, where fx is equal to log of sec x plus tan x whole cube. Then fx is oblique r, odd function, then 1 1, then onto, then even function. Actually, if this type of options result is this type, is oblique r, means it may have more than one option correct. So let us see one by one. F of minus x, you see, f of minus x is log of sec of minus x, sec x, plus tan of minus x is equal to minus tan x whole cube is equal to log of multiply numerator and denominator by sec x plus tan x. It become log of sec x minus tan x into sec x plus tan x by sec x plus tan x whole cube. It is actually sec squared minus tan square 1. So log of 1 by that sec x plus tan x whole cube is equal to minus log of sec x plus tan x whole cube. So it is equal to minus of fx. So f minus x is equal to minus of fx. So it is an odd function. So first option is correct. Second, let us verify whether 1, 1, on 2, etc. they are correct or not. So this is definitely not correct because this is even function. It is already proved that this is odd function. So this is not possible. To find whether it is 1, 1, if the function is actually increasing function or decreasing function, then it is 1, 1. For that purpose, f dash x is equal to fx is this. It is 3 into log of sec x plus tan x whole square into log of this derivative of that is 1 upon sec x plus tan x into derivative of that. Derivative of sec x is sec x tan x. Derivative of tan x is sec square x is equal to 3 times log of sec x plus tan x whole square into, taking sec x common, it is sec x into sec x plus tan x cancels. So only sec x. Now f dash x and its interval is this minus pi by 2 up to plus pi by 2. This is positive no doubt because it is whole square is present, and sec x or rather cos x is positive in fourth and first quadrant both. So sec x also positive. This is positive, this is positive. So it is positive. Then f dash x is positive. Well, fx is increasing function. If increasing function, it is 1, 1. Now we see whether it is onto or not. The function is continuous because this function is continuous. So it's for x is equal to minus pi by 2. This is minus infinity whole cube. So it is when it is very near to minus pi by 2, it goes to up to minus infinity almost. And for plus pi by 2, it goes to plus infinity. So it starts from minus infinity and up to plus infinity, and it is continuous function. So it will assume all values between minus infinity to plus infinity, that is all values of r. So it is onto. So it is odd function, 1, 1, onto, and not even. This is not. So these three options are correct. So, okay. If you feel that the video helps you, then you please subscribe it. Okay. Thank you.